Okay, another method of attacking exponential equations. If you have something like 2 to the x power equals 32, one way to do this is to count powers of 2, but that only works if you have nice numbers here. With this, you can go 2, 4, 8, 16, 32, and you know in a second that the answer is 5. But if this is like 1.73 to the x equals 4.7419, you don't have much chance of counting out the numbers in that case, so we need another approach. The other approach is, or one of the other approaches is log both sides of the equation. Now, why would you bring logs into this, for crying out loud? Well, because once this is in log form, we have the power to take this exponent down in front. It's one of the only things we can do with a variable exponent like this is use logs and then the down in front rule. That gets us x log 2 equals log 32. Now if you want to solve for x, you just divide by log 2 and you get x equals log 32 divided by log 2. Log 32 divided by log 2. Ta-da, there's your 5. So obviously a waste of time with nice numbers like 2 and 32, but this is indispensable when these numbers get bad, and they're going to get bad. We're going to do real-life questions with radioactive decay and compound interest and stuff where these numbers are all over the place, and they're not nice powers of each other. So if you've got an exponent up here and you need to get it down, your first step is log everything, because once you have logs, you have the power rule. They give us another one to work with here. 4 to the x power equals 2 to the x plus 3 power. Again, if we do logarithms on both sides, we can take this x out front, we can take this x plus 3 out front, and we get here x log 4 equals x plus 3 log 2. Now this one's not so nice. It's not so easy to get all the x's to one side and all the numbers to the other. But we can still do it. What you do next, this is messy, but it does work. It completely works. We'll find log 4, and we'll find log 2. We're going to need both of them. Okay, log 4 is 0.602. So here we have x times 0.602. And then we have x plus 3, and log 2 is 0.301. Rewrite that a little bit. 0.602x equals, this 0.301 distributes through the parentheses, so we get 0.301x plus 0.903. Get all our x's to one side. This is ordinary algebra that you've done a gazillion times. It's just now we're doing it with very unpleasant numbers. And if you divide that out, you should get x equals 3. And if you work this out algebraically, I believe you can find 3 works just fine.